So with right triangle trigonometry, it's all going to deal with right triangles. A right triangle means it has a 90-degree angle in the corner, and that 90-degree angle is denoted by that square box. And what else can we say? The side across from that 90-degree angle is always the hypotenuse. And your hypotenuse is always across from 90. It's always the longest side. Always has to be the longest side. And it's usually denoted with a lowercase c, your hypotenuse. In a triangle, your angles are always capitals. So you put like a capital A, capital B, capital C. Triangles are always capital. And your sides are always lowercase. Sides are always lowercase. And your sides, most importantly, sides are across from or opposite from their angle. So if this is angle A, then side A is over there. If this is angle B, then side B is over there. If this is angle C, then side C is over there. So angles are always opposite their sides. And we also know that the sum of the angles, in any triangle is 180 degrees. Things to know. Right? So angle A plus angle B plus angle C always equals 180 degrees. In addition, anytime we see this, this is theta. Right? Theta represents, I don't think I could talk and write at the same time, represents an unknown angle. Unknown angle. Theta represents an unknown angle. So it's just like having x there, but it gives you more information because by it being theta, you know it's an angle. In fact, any Greek letter, the book uses a lot of different Greek letters, and when they have Greek letters, it's an angle. It represents an angle. I always use theta. Some other things you should know or note that you probably already know, hopefully, is complementary angles. Add to 90 degrees. There are two angles that add to 90 degrees. Two angles that add to 90 degrees. And supplementary angles are two angles that add to 180 degrees. Complementary and supplementary. So with all that information, if in this example, I said, we'll call this example. In this example, if this angle was 37 degrees, and I said, find the value of theta, Well, there's two ways you could think about this, right? If I was in a live classroom, I would have students give me two different avenues to take. Some students will plug it right into this formula here, right? And they would say A plus 37 plus 90 equals 180, which is fine, right? And then they would add the 37 and 90, subtract it from 180, everything would be great. It's not a problem. But what I want you to understand every time you see this is that this angle, since all triangles add up to 180 degrees, well, if this is 90 degrees, then these two also add up to 90 degrees, right? So I know theta plus 37 is equal to 90 degrees. These angles are always complementary angles. So you don't, it's just a shortcut. As long as you're aware of it, you could say if these two always add up to 90 degrees, it's an easier problem, because then all you have to do is subtract 37 from 90, and we would get theta is equal to 53 degrees. Okay, it's just an easier way of looking at it. So the relationship between angles in a triangle is that they all add up to 180 degrees. The sides of a triangle have a relationship also, and the sides of a triangle have a relationship that's so difficult having nobody to talk to. I would say, what's the relationship of the sides of a right triangle? And then inevitably, hopefully, somebody would say Pythagorean theorem. Pythagorean theorem, which is a squared plus b squared is equal to c squared, which means the two legs, or the squares of the two legs of the triangle, is equal to the hypotenuse squared. Right? And again, I'm sure this is all review, so let's do one real quick. So if I said A is 5 and C is 11, find side B, you're going to be able to do that for me. Find side B. I'll give you a second to work on that. So if we have to do this problem, I know that A squared plus B squared equals C squared. And I'm going to let A be 5, so I have 5 squared plus B squared is equal to 11 squared. So I have 25 plus B squared is equal to 121. I want to get B squared by itself, so I'm going to subtract 25 from both sides of the equation. I have B squared is equal to, was it 96? 121 minus 25, 96. So if B squared is equal to 96, and I want to get B by itself, I'm going to have to take the square root of both sides. So B is equal to the square root of 96, which is the exact answer. If we found a decimal approximation, we could say B is approximately, and if we do this on the calculator, the square root of 96 will give me approximately 9.8. So that would be our answer rounded to the nearest 10. If they wanted it in the simplest radical form, well, we'd have to simplify this 96. We'd have to break this up to simplify this radical, right? We'd have to say, what's the largest perfect square that goes into 96, which is 16. And then the square root of 16 is 4. In simplest radical form, oops, I wrote, this should be a 6. 16 times 6. 16 times 6 is 96. So this would be 4 radical 6. You can check that on your calculator too. You could do 4 times radical 6 and you should get 9.8. So that's all basic stuff that you should generally come in here. Even in college algebra and trig, most students have that down pat. The trig is the relationship between the sides and the angles. And that's what trig does. Right? The relationship of all my sides can be covered by Pythagorean theorem, and the relationship of the angles of a triangle can be done, the sides of a triangle, Pythagorean theorem, and the angles could be done, the sum of the angles is 180 degrees, so it's no big deal. But what your trig functions do, your 6 trig functions, you have sine, cosine, tangent, cosecant, secant, and cotangent. Right? These enable us to create a relationship between sides and angles. And these are usually abbreviated. You never see them like this. You'll see sine is usually S-I-N, and cosine is C-O-S, and tangent is tan. Cosecant is C-S-C, secant is S-E-C, and cotan is C-O-T. And when we have sine of an angle, we say it's equal to the opposite side over the hypotenuse. Now, let's take a look. We're talking about an angle, so we could refer to it. Right? If we have theta over here, then my opposite side would be here. My hypotenuse would be here. And this side over here we call adjacent. And this changes depending on where our triangle is. Where our unknown angle is. So if theta is up here, then my opposite is now down here. And my adjacent, which means next to, is over here. But my hypotenuse never changes. My hypotenuse is always my hypotenuse. So it says sine of theta, sine of an angle, is equal to the opposite side over the hypotenuse. So it's a ratio of 2 sides. Cosine of an angle is equal to the adjacent over the hypotenuse. And tan of an angle is equal to the opposite over the adjacent side. Right? So if you don't already know these, an easy way to remember it is, I don't know if it's really an acronym, but we call it SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. It's an easy way to remember it. SOHCAHTOA. But that only gives us the first three trig functions. Well, the nice thing about this is if sine of theta is opposite over hypotenuse, cosecant of theta is the reciprocal, hypotenuse over opposite. These two are reciprocals of each other. Similarly, cosine of theta, my adjacent over my hypotenuse, secant of theta is the reciprocal of cosine. My hypotenuse over my adjacent. And same thing with tan. If tan of theta is equal to O over A, then cotan of theta is A over O. So once you know these three, it's easy to find the remaining, oh my goodness, to find the remaining three. So let's do some problems. Well, let's look at something easy. Might ask, find the function value of theta right? And they'll give you a triangle and it'll be like, find the function value of theta for sine, cosine, and tangent. So if the question asks, find the function value of theta for sine, cosine, and tangent, well, I'll help you with sine. Well, I know sine of theta is equal to my opposite over my hypotenuse. So my opposite over my hypotenuse, that would be 3 over 5. So they want you to find cosine of theta and tan of theta. Find the function value, the value of the function, right? This is the function. What it's equal to is the value of the function. I'll give you a second to look at that. So cosine we know is A over H, my adjacent over my hypotenuse. From this perspective, my adjacent is 4. My hypotenuse is 5. Tan, TOA, O over A. My opposite over my adjacent, 3/4. And if it asked for all 6 trigonometric functions, we could easily find cosecant, secant, and cotan by taking the reciprocals, right? Cosecant would be 5/3, secant would be 5/4, and cotan would be 4/3. Let's turn the page. So in this example, it's going to say, I'm going to put theta up here. find the 6 trigonometric function values of theta. I'm going to read what it says actually in the book, but that's what it's going to say, something to that effect. You can try those. Find the value of each of the 6 trigonometric functions of theta. That's how it's stated. So that means they want you to find sine theta, cosine theta, tan theta, cosecant, secant, and cotan theta. Given this information. So theta is up here, right? So sine is easy enough. It's my opposite over my hypotenuse. Cosine is my adjacent over my hypotenuse. There's no value given here. So you have to find that value. First thing you're going to have to do is find side A. You're not going to be able to answer this without side A. And in order to find side A, you're going to have to use Pythagorean theorem. So I'm going to have a squared plus 15 squared is equal to 17 squared. So I'm going to have a squared plus 225 is equal to 17 squared. What's 17 squared? 289, I think. I don't have a calculator. So if you use Pythagorean theorem, you'll get A is equal to 8. And once we find that side, this is a relatively easy problem. So again, sine is my opposite over my hypotenuse. So it's going to be 15 seventeenths. So that means this is going to be 17 fifteenths. And cosine is my adjacent over my hypotenuse. So my adjacent in this case is 8. I'm going to have 8 seventeenths, and this will be 17 eighths. Tan is my opposite over my adjacent, so it's 15 over 8. So cotan is 8 over 15. So we would be able to find all the values of all 6 trigonometric functions. I think that's enough for today. So we did a lot.